The quiz will be next Thursday. All right, 4.3a. Okay, we're gonna extend our trig. So we've only been in the quadrant 1. We've had acute angles. So we're going to do a trig extended. And we're going to extend this to the circular functions. Okay? All right, so let's first start by talking about any angle. So far we've only done, 0 to 90 or 0 to pi over 2. Today we're going to open it up. So you know that in a standard position angle will start with its initial side here on the x-axis, and if you rotate it open in a counterclockwise direction, you will get a positive angle. Okay, positive angle. Now, you should be getting more comfortable every day about radians as opposed to degrees. And so this is 0, this is pi over 2, and this is pi, and this is 3 pi over 2. Okay, so that would be a positive angle in a clockwise direction. Now I can also draw a negative angle in standard position, okay, still going to have its initial side on the x-axis, but I'm going to open it up in a counterclockwise direction. So maybe I go over to here. Okay, so that angle is going to be between 180 and 270, negative. Okay, so this might be, let me see, what would we call that angle? This could possibly be the angle negative what, 225, maybe? Okay, negative 225 degrees. Because I went to 80, and then I went past it another 45 degrees. Does that make 225? Yeah, I hope so. Okay, so there you go. So these are negative angles going in a clockwise direction. Positive angles go in a counterclockwise direction. Now, you can also have an angle that is more than 360. Okay, so an angle that is more than 360, you would start once again on the x-axis, and then you could go around 1, 2, 3. What if I ended up there? Okay, so that angle I would call 3 pi. That's the angle 3 pi, because I went 1, 2, 3 pi all the way around. You could also call that angle, hold on, 540 degrees, because I went 360 and then I did another 180. Okay, so those are angles. You should be pretty familiar with them. Now, as you notice, these two angles that I drew up here, one went the positive and one went the negative, and they kind of ended up in the same place. Those are going to be special angles of each other. Those are called coterminal angles. Coterminal angles. Now, an initial side is the starting side, and a terminal side is the ending side, right? Terminal. That's why airports are called terminals, because you're going to end your life. Yeah. So, I'm just kidding. All right, coterminals. So, coterminal angles, basically, they have the same, I'm afraid to fly, as you know. They have the same initial and terminal sides, but they're different angles. Okay, well, how can we tell them apart? Well, that's why you need that arrow. Okay, the arrow tells you which direction to go, what kind of angle it is. So, for example, let me show you visually what this looks like. So I'm going to draw this green angle, and let's say the green angle is, I don't know, we'll call it 50 degrees. Okay? By the way, coterminal angles, there's an infinite amount of them. Everybody has an infinite amount of coterminal angles. So let me draw another angle that would be coterminal to 50 degrees, would be the angle that, has the same initial side, but it goes in this direction, and it has the same terminal side. That's all a coterminal angle is, coterminal with terminal. They have the same ending side. but that's a totally different angle, right? What is that angle? Negative, anybody want to guess? Starts with a 3? 310, yes. Negative 310. So all you did was take 360 and subtract 50 from it, right? Yeah. So that's negative 310. Those are called coterminal angles of each other. They have the same initial and ending side. Now there's a really easy way to find coterminal angles. You are either going to, if it's in degrees, add or subtract 360 degrees. Okay. If it's in terms of radians, you're going to add or subtract 2 pi. And that's how you can find them. Okay. So let's start. Here's our first problem of the day. Number 1. We are going to find and draw a positive and negative angle coterminal with the given angle. Okay? Let me write that down. Find and draw. So we're going to draw some pictures. I want you to get used to what these look like when you're going positive, negative, and the arrows and the directions and stuff. Find and draw. You're going to find 2 of them. A positive and a negative coterminal angle. Coterminal angles are going to be important later on. Right now we're just learning how to find them and what they are and get used to them. Okay? So you're like, what are these used for? Not yet. We're not there yet. All right, so here we go. Let me give you 30 degrees. 30-degree angle. We need to, and if it's given to you in degrees, the answers should be in degrees. If it's given to you in radians, the answers will be in radians, okay? So let's go ahead. We're going to find and draw a positive and negative coterminal angle to 30 degrees. It's pretty easy. This problem is pretty easy. All you need to do, really, is add and subtract 360, and you'll get a positive and you'll get a negative coterminal angle. I mean, it's really that easy. You don't have to understand it if you just do that every time. It's better to understand it, though. Let me draw a 30-degree angle real quick. So a 30-degree angle would be about here. It's pretty small in the first quadrant. That's 30 degrees. Okay? And then a coterminal angle to this would be to take 30 and add 360 to it. So how much is that? 390. And let me draw what that looks like. I'll draw it in red. Let me write it over here. 390 degrees would be to go past the 30 and then end there. See how it started in the same spot? It starts here, and I went past 30 degrees, and I went around 360. That would be 390 degrees. They're coterminal. They're the same initial and ending spot. They're not the same angle. They're not the same. 30 degrees and 390 are not the same, but they are they are coterminal. And the reason why, I'll kind of jump ahead real quick. If we're going to take the sine of 30 degrees and you're going to take the sine of 390, guess what? These are going to be equal to each other. Okay? Yeah.
So why don't we use the two, like have the coterminal angles be the ones that equal 360? Why wouldn't we have 30 degrees and 330 degrees?
I'm going to do that one next.
Oh.
Yeah. So this is just the positive one. That's the positive one.
Yeah, but I mean, like, why would it be about 360? Why wouldn't we just use
330? Oh, the angle 330 would be over here. So it has the same initial side, but it doesn't have the same ending side. Yeah. So we want it to start and end in the same spot. In order to do that, I would have to go around 360, and then I'm there. I'm back there. Remember, like that Weight Watchers 360, you're right back to where you started from. So if I go to 30 and I go 360 more, I'm still at the same spot. Okay, so here we go. Let's do the other one. So I needed a positive and a negative. So how do we find, oh, you can put that on my desk, thanks. How do we find a negative coterminal angle? That would be to go the other direction. Okay, so I'm going to start here, and I'm going to go backwards. All right, and what angle is that? Well, that's just 30 degrees minus 360. So that would be negative 330 degrees. So we found two. We found a positive angle and a negative. And by the way, there's infinite answers to this. If I took 390 and I added another 360 to that, that's another one. Add 360, another one, another one, another one. And same thing with subtracting 360, another one. Okay? All right, let's do now, let's start with a negative. Let's say I have negative 175 degrees. I'm going to find two coterminal angles, one positive and one negative, and I'm going to draw them. Okay? Now, when we draw these, they don't have to be exact. You know, we're not getting out our protractor. You probably don't even own one anymore, do you? Do you know where that thing is? No. I think I have one, but we don't need it. So negative 175, you need to be like in the area of negative 175. Do you know what quadrant that would be in? What quadrant would that end up in? 3. Quadrant 3. So this is quadrant 1, 2, 3, and 4. So negative 175 is going to start on the x-axis, right here, and it's going to go in a clockwise direction to almost to 180, but just 5 degrees shy of that. Okay? So that's what the angle would look like if I were to draw it. That's what you were thinking, right? Okay, so the way that you're going to find the coterminal angles to this is you're going to take negative 175 degrees, oopsie, and you're going to add and subtract 360 from it. Okay, I mean, it's really that easy. Like, some of you don't even have to understand it. Some of you won't understand it, and you're just like, okay, I'm going to add 360, and I get 185, of course. And you can see that visually. 185 would start here, and I would go 180, and then 5 more, and I end up at the same spot. 185, and then I would take negative 175 and subtract 360 and get negative, let me do this in this color, negative 535 degrees. That would be an angle that would go past it and then back around to it. And that's how you draw it, the yellow one. All right, let's do a radian measure. Okay, here we go. Let's do negative pi over 4. Do not convert this to degrees. Keep it in radians. Our answers are going to be in radians. Okay? So negative pi over 4. Let's first draw that. Negative pi over 4 is going to start on the x-axis, and it's going to go in a clockwise direction to pi over 4. Now remember, pi over 4 is halfway to pi over 2. This is pi over 2 here in this direction, negative pi over 2. Okay, so I would want to go to here. That would be negative pi over 4. Remember? So the entire thing is a pi. The entire bottom half would be to go pi. So this would be pi over 2. That's 3 pi over 4. Okay. So negative pi over 4. So I'm going to take this, and I'm going to add and subtract 2 pi. All right. So let's take negative pi over 4, and I'm going to add 2 pi to that. Adding 2 pi is the same thing as adding 8 pi over 2. Do you agree? Yeah. I'm sorry. No, you don't agree. 8 pi over 4. My bad. 8 pi over 4 is the same thing as 2 pi. So a negative 1 plus positive 8 gives us 7 pi over 4. That would be one of my angles. 7 pi over 4 starts here, and it goes all the way around and ends here. Same spot. That's 7 pi over 4. It's 1 pi over 4 short of a full 2 pi. And then the other one that we need would be to take negative pi over 4 and subtract 8 pi over 4, and that would give us negative 9 pi over 4. Negative 9 pi over 4 starts at the x-axis, and it goes past it and then ends there. That's negative 9 pi over 4. It's negative 2 pi, which is 8 pi over 4, and then one more quarter of a pi. Yeah, fractions. Do you like fractions? Not so much. Okay, let's move on to part B. We're running out of time. Okay, we're going to talk about reference angles now. So reference angles are going to be important also. See, we're getting to the point where we want to evaluate the sine of 135 degrees. Right now, you only know how to evaluate the sine of acute angles. We're opening it up to the whole thing. So reference angles are going to help us with that. Now, a reference angle is a positive angle from the terminal side to the x-axis. From the terminal side the terminal side of your angle is the ending side of it, terminal side, to the x-axis. That's going to be called a reference angle. And you might write that down and think, don't know what that is. Okay, I'll show you. Here we go. Quadrant 1 is pretty basic, okay? If we have an angle in quadrant 1, right here, the reference angle is just the same angle that it is because it's the angle from the terminal side to the x-axis. It's the same exact angle. Okay, so we don't need a reference angle when we're in quadrant 1. Quadrant 2, 3, and 4, you will. So let's look at those. For quadrant 2, let's say that we have an angle that goes over to here somewhere. Okay, there's an angle that has a terminal side in quadrant 2. Now its reference angle is the angle between the terminal side and the x-axis. Do you see that angle? It's between the terminal side and the x-axis. Oops, that was kind of gross. Let me draw that a little straighter. There we go. That's the angle, the red one there, that's the reference angle. So we call this angle theta, and we call the reference angle theta prime. Theta with a little apostrophe above it, that's called theta prime. That's the reference angle. What's the big deal about reference angles, you ask? Well, I'll tell you. If you were to take the sine of theta, it's going to equal the sine of theta prime, depending on the sign. We'll get into that in a minute. All right, let's look at quadrant 3 now. Oopsie. The reference angle for quadrant 3, so let's draw an angle that ends up in quadrant 3. So let's start here again. We'll go around to here. Okay, so that's an angle that has its starting point on the x-axis and its terminal side in quadrant 3. And so we call that theta. The reference angle to theta is theta prime. And remember what it is. It's always the terminal side to the x-axis, never the y. Don't ever think of this angle here. That angle doesn't matter, okay? It's this angle right here that we want, and we call that theta prime. That's the reference angle.
Wait, what about, you wouldn't ever, would you call
positive. It's always going to be positive. So it's this little angle here. So for example, let's get an actual number, okay? Yeah.
Why wouldn't it be the other way to the x-axis?
Over here?
Yeah.
No, we want it to be, oh, okay. You know what? I didn't write that down. Positive acute angle. Thank you. Yes, positive acute angle. We want all of them between 0 and 90. All right, so let me give you like an actual number. So let's say that I have an angle in quadrant 3. Let's say it's 210 degrees. So theta equals 210 degrees. What would theta prime equal? If I went over to quadrant 3, let's draw a picture of this. Pictures are going to help you a lot. I know you don't like drawing, it takes a long time. You're going to go past 180 and then a little bit more. So how do we find out what that angle is there? Subtract 180. Perfect. What is that angle? 30 degrees. Okay, that's going to help you a lot, a ton. Because the sine of 30 and the sine of 210 will be the same, not the sign of it, not positive or negative. We're going to get into that, but that's going to help you find out all of your trig values of numbers, okay? All right, and then finally, quadrant 4. All right, quadrant 4, you're going to go to here, and here's our regular angle, goes all the way around. Okay, that's theta. And then theta prime would be, the reference angle in here would be theta prime, positive angle going like that. That's our reference angle. Okay, so let's go like, let's say you have a 300 degree angle. What is its reference angle? Those are a little easier to find. Okay, they're different in every quadrant. You're not just going to add 180 or subtract from 180 or, you know, stuff like that. This one is 360 all the way around. You would subtract 300. So what is that angle then? 60 degrees. Perfect. It's so nice when you have a picture too. Okay, so here we go. Let's go ahead and do another problem. What are we on, like number 2 or something? It's a lot of like knowledge, and then we get to do some problems. All right, number 2. We're going to evaluate all 6 trig functions. All 6 trig functions. You did this last night. You did this with acute angles in quadrant 1. With the terminal side of your angle, ending at the point -4, -2. Now, here's where we get into triangles that have negative side measures. It's going to be weird, but it's true if you're going to set up a triangle. Okay, so first of all, do you know how to graph the point -4, -2, right? Let's go ahead and graph that. So our angle that we're talking about starts here, and it ends at -4, -2. So our point would end right here. So this is the angle, this is theta, that we want to find the sine of theta, the cosine of theta. Can I draw a triangle out of that angle? No, the angle's over 180. Can't draw a triangle with that. So what we're going to do is we're going to use its reference angle instead. Okay? The reference angle is the x-axis to the terminal side. You're going to drop a perpendicular, and this angle inside of here is theta prime. Okay? Now, I can do that because the sine, cosine, tangent of theta is going to be the same thing as when I take theta prime. It's exactly the same. I can just use this triangle. Make sure that you keep your signs though. Okay? This side right here of this triangle is -4. This side right here of the triangle is what? -2. The hypotenuse will always be positive. So the hypotenuse is going to be -4 squared plus -2 squared equals c squared. What is that? Square root of 20? So 2 rad 5? Okay, so 2 rad 5. The hypotenuse is always positive, and the sides can be negative. In quadrant 3, both sides are negative. In quadrant 2, only one side is negative, okay? All right, and now we can evaluate. We have what we did last night. So if you find the sine of theta, it's really the sine of theta prime, but still same thing as sine of theta, you're going to do opposite over hypotenuse. So you get -1 over rad 5, which is negative rad 5 over 5. That would be the sine of theta. All right, the cosine of theta is going to be -4 adjacent over hypotenuse, which is -2 over rad 5, which is -2 rad 5 over 5. Okay? If you want to find, if we have to find all 6 of them, which is kind of a pain in the butt every time, you should go to this and flip this right here, the -1 over rad 5. So this would be negative rad 5. And if you want to find the secant, did it make it? Is it okay? It's all right?
Yeah.
Oh, phew. That scared me. All right, and then this one would be negative rad 5 over 2. So flip this before you rationalize it, or else you're going to have to rationalize again. That's a pain in the butt. Okay, now let's look at tangent. The tangent of theta is TOA, so opposite over adjacent, and you get 1/2, and the cotangent would be 2. Now, let's go ahead and talk about our answers here a minute. I got negative, 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 positive, positive, okay? There is a thing that we're going to write down that's going to tell us which trig functions are positive or negative in each quadrant. So here we go. You ready for this? This is going to help you. You're going to love this. Right now you're going to be like, whatevs. But you're going to love this later on. Okay? So in quadrant 1, all 6 trig functions are going to have a positive value. Because your triangle is going to have positive sides. Okay? Over here, only sine and its reciprocal. Okay, the reciprocals are going to go with it. Only sine is going to be positive in quadrant 2. All the rest of them, besides cosecant, all the rest of them are going to be negative. Okay? So this is positive, positive. What did we find out was positive here? Tangent and cotangent. Okay, is positive. And then what do you think is going to be positive over here? What are we missing? Sine, cosine. Cosine and its reciprocal will be positive in quadrant 4. All right? So the way I've always remembered this, the way I learned this when I went to Valley, was all saints trust Christ. Yeah. And then I brought that out to the public schools, and they didn't really like that so much, so that's okay. So when I was in college, I was like, oh yeah, all saints trust Christ. And then my heathen friends, they were all, no, all students take calculus. I was like, oh, that's funny. And then people were like, all sinners try cocaine. It's like a whole bunch of, all sisters take clothes. There's a whole bunch of them. So you can make up your own, but I always do all saints trust Christ. Okay? And so that's the way it's going to be. So if I'm finding the sine of, 175 degrees, I know my answer needs to be positive. It has to be positive. It will be positive. All right. It says don't skip, but I feel like I need to skip that because we don't have any time. I'm going to have to skip it.